Good morning, everyone. I hope I'm now enough. Thank you very much for making your journey all the way to London. We have Ian coming from Inverness, all the way from Scotland, and we have Simon. Like they both come from Cornwall, from the south. So thank you so much for making the effort, and hello to everyone virtually as well. Thank you for joining us today. I have prepared my very short intro earlier, but it's still sitting in my laptop, but it doesn't matter. I think we can be very flexible and be very creative today, and then test our boundary and see how good we can manage meeting like this. Just a very quick housekeeping. The bathroom is on the like when you go outside, when you see the double wooden door, it's just behind that. So if you need hello, that's where it is. Our time is a little bit flexible today, so I think each session is about 1.5 hours. If you have any questions, like you want to ask, or you want more discussions, that's fine, because we do have quite a long break and a long lunch time. So just to give you an opportunity to kind of like talk to each other and do some networking. Because from the previous meeting feedback, I think networking is the major theme. Everyone really enjoy and taking advantage of the opportunity, talking to other quality manager, across the country. So take advantage of that, please. And so because we're organizing this virtually, we would like to kind of make this as inclusive as we can. So if you don't mind, just come up this way, just to give a very short 1-minute introduction of yourself, like to our virtual audience. That would be really great. All you need to do is just like me, stand in front of the laptop and talk to your laptop. So I'm Isabel. I know most of you in the room. So I am the quality superintendent at the Harley Street Clinic. So welcome, and I hope you enjoy the day. Any question, just come and grab me when you need me. Okay, right, shall we start from this table? Johnny?
Yeah. I think I'm lined up. Hello, I'm Johnny Lee. I'm head of radiotherapy physics at Poole Hospital. My sort of main reason for attending here is we've come off the back of a sort of spate of reportable incidents. We're looking to improve things and hope to pick up some nice ideas.
Hello, I'm Matt. I'm the treatment superintendent at the London Clinic, and I'm just here because the speakers that were scheduled looked really interesting. So, forward to hearing from them.
Hi everyone, I'm Deirdre Moran. I'm the quality lead at the London Clinic. This is my first meeting, and I'm just filling some of Isabel's big shoes at the moment.
Hi, my name is Umesh Prabhu. I was a consultant pediatrician. I developed interest in patient safety after my own mistake. I became medical director. I was medical director for 15 years, and we reduced harm in vegan by 90% in 5 years. If you don't know anything, just follow me on Twitter. I met Jeremy Hunt, I met Matt Hancock, everybody. I'm here just to take some notes. I'm an 8th boat rocker in the country. I was in South Africa. I'm the first boat rocker.
Hi everyone, my name is John Lodge. I'm Head of Quality Improvement for the London region at NHS England, and I'll be talking to you just before lunch about statistical process control. See you in a bit.
Hi, I'm Matthew Meze. I'm Q's Community Manager, and I'm kind of mainly here just to support Isabel and see what this great group is up to today.
Hi, I'm Helen Best at Public Health England. I look at patient safety. I collate, analyse and disseminate all of the radiotherapy errors that are reported across the UK.
Hi, I'm Corinne Cook from Oxford, Quality Manager. Been in the laser group for a long time and therefore know a lot of people in the room, but it's good to meet everybody and just get a bit more networking.
I'm Victoria Stoffel. I'm also from Oxford, working alongside Corinne. I'm on a secondment.
Morning, I'm Gail Threlfall. I'm the chair of the Laser Group and remaining founder member, and I'm here on my last Party QSIG meeting. So I hope you all have a good day. Thanks.
Hi, I'm Guy Siddle. I'm quality manager at Mount Vernon Cancer Centre.
Hi, Rachel Westcott from Barts Health NHS Trust.
Hello, I'm Mark. I'm from Leicester. I'm a dosimetrist. We don't have a quality manager at Leicester, so we share the work between myself and this person here.
Hello, I'm this person here, also known as Catherine Broxop. I'm a radiographer from Leicester.
Hi, I'm Kathy Broadbent. I'm a physicist from Cambridge, working mostly in machine dosimetry.
Hi, I'm Andrea Hurst from Sheffield. I do quality management for the radiotherapy side of the scope, and we also have somebody working with physics, which is the other half. Currently also leading on service improvement for the department and involved in transformation and strategy.
Hi, I'm Donna Forsyth. I'm Head of Investigation at NHS England, NHS Improvement, and in rewriting the Serious Incident Framework for the NHS.
Hi, I'm Carol Matthews. I'm the Quality Manager in Singleton Hospital in Swansea. Nice to meet you.
Hello, I'm Ian Dean, Radiotherapy Physicist and Quality Manager from Inverness.
Hello everybody, my name's Simon Whiteley. I'm a System Safety Engineering Consultant and I'll be speaking this afternoon about cast accident analysis. I'll be honest, I don't actually know too much about radiotherapy, not ology, therapy. Yeah, she's already told me about that. So thank you very much for the opportunity to speak and I'll see you this afternoon.
And then I'm going to introduce Simon, like he's our first speaker, and I'll let you, Oh, yes. See? This is a new way of working. I have to get used to it. Right. Let me read.
Yeah, just scroll.
Is that touch screen?
No.
Right, now I'm scrolling. So let me pick up from the chat room. So first we have Karen Wade. She is the quality manager from Nottingham, and she's also the deputy chair of the Radiotherapy Quality Special Interest Group. Unfortunately, she's not able to make it today. And then we have Giles. He's the Linac engineer and deputy in QA at the World Free Hospital. Then we have Rita from the guys in London. Did I miss anyone? There's a couple of above. Yeah, I thought there are more. Okay. I think Hussein, he mentioned earlier, I saw he's from, he's a quality lead from Basingstoke. And then we have Javaria. She's the quality manager at the World Free. And let's go up, go up, go up. And we have Fiona. She's the quality manager at Guildford. And then Minnie. Further down. Minnie, how can I forget you? Where are you? Oh, yeah. Oh, yes, we have Minnie from Guildford. I am not sure. Sorry? Oh, sorry, Minnie. Minnie from Wedding. I don't know if Alison is joining as well, but there's 2 new messages. Right, going down. Oh, I got Hussein. Hussein, the radiotherapy quality physicist from Genesis Care. So, did I miss anyone? No? Happy? Right. Okay. Let me hand this over to Simon, our first speaker. Thank you.
Morning, everyone. Yeah, my name's Simon Gill. I'm an aviation predominantly resilience risk safety specialist, but together with my business partner, who is chair of a hospital trust, we do a lot of work applying the aviation risk and resilience concepts into health and social care. So what I'd like to talk to you today about is resilience and resilience engineering. It is something you will have heard of. It is something that has been talked about quite frequently. It is in the academic sphere, and it is creeping into practice. So what we're going to do is just to unpick that a little, and just to make sure that the fundamentals are clear, because my reading of it is that it's not always clear. And I just wanted to unpick it, and actually, as we have got a small group, thank you, we have the opportunity to interact a lot more than a large group. So let's look on the bright side of everyone not being able to make it. So I think the bottom line. So I worked. I was a human factors manager at Airbus, the plane manufacturer. I had a team of psychologists and engineers working together to ensure that we considered humans when we designed aircraft, and that was how we started, and we essentially, that's how we worked. But as I was working and as I left Airbus to finish my PhD and consult, more and more I was observing the resilience of the safety community starting to question themselves and question what they were doing and their effectiveness. And you started seeing more and more phrases around the sphere of safety. And it was absolutely clear that safety was going through a crisis of confidence and identity. What was safety? Are we actually being effective? Are we doing what we want to? So what I'd like to do is to talk today about that crisis. So why was there this crisis? Why do we need to change? So what is the driver? What is the reason why there is a perception of a need to change? And how can we do safety differently? So what is the alternative? How do we do it? But how does it apply to organizations? So I'm going to talk through, it's actually going to take me quite a long time to get to radiotherapy. One, covering up my absolute lack of knowledge of radiotherapy, but also because actually we are doing risk analysis all the time. And I just wanted to give some metaphors from outside of aviation or healthcare. So how does that apply to radiotherapy? So we're going to start to unpick that. And then really, as I say, a lot of resilience and safety too is in the academic domain. So what I want to do is really give you some things to think about from tomorrow, from you going back into your offices, and focus on the power of conversations. So this is going to be quite a struggle for you guys on Zoom, but we're going to have some conversations here in the room. So if you can manage to do that as a virtual room, I will be very impressed. So that's how we're going to run today, this morning. So first of all, why? Well, what I'd like to do is really start with an analogy. I live in Cornwall. I live on the south coast and my office is on the north coast. So I have a commute across Cornwall whenever I go into the office. Now, that takes me on some very windy Cornish country lanes. And this particular stretch of road I take every time I go into work. And it's very windy and it's very steep. And then there's a left-hand bend that takes you round a reservoir. Now, this was built in 1967, according to the rules at the time. The highway code, I pulled out highway code that was active from that time, and it talked about protection from your reckless behaviour. It was very, the whole way of advising drivers was very different. the way of actually designing roads was different, the way of putting protections in place was very different. And effectively, that road hadn't changed since 1967. And in 2016, a mother of two lost control going around that corner after the steep section of road. The car overturned into the lake, and she died at the scene. So obviously, this is a hugely tragic event, and in Cornwall there was massive talk about it in the local press. There was an investigation, as you would imagine, and this is 2 quotes from the investigating officer. So clearly the investigation saw that there was evidence of multiple collisions at this place. So the investigating officer found debris from previous collisions. And then he spoke to local residents and found that actually the local residents got so fed up with cars going through the fences that they stopped bothering to fix them because there were so many things going on. And as you would imagine, the result was that a new safety barrier was put up, so that accident could not happen again. That section of road is very well protected. So this is quite typical of the way in which safety operates. We very much look back at failure. We observe failure. We take lessons from failure, we put in place solutions, we put in place new control measures or safety barriers, and we move on. We focus very much looking backwards and looking at failure. Now, that doesn't necessarily mean we wait for people to die. We look at near misses or near hits, as they should more accurately be termed, and we really focus on those as well. So it's we're not we don't wait for things to go badly wrong, but it's clear that we do need to do something differently. We have since for a long time known about the influences on performance. So a human operating has multiple different things affecting their performance. So this model, when I first started in safety, was the shell model. It's now the seashell model. It is the focus on the influences that we have. So there's software that we use on a daily basis, and many different software programs that we're using. Obviously, there's hardware, both in terms of computing hardware, but there's also the equipment we use, the digital equipment, but the physical equipment. Huge amounts of hardware that we use to interact with patients. There are multiple livewares. So livewares are the interactions between people. So that's between you as colleagues, you and your patients, you and the patient's family, you as colleagues here, you within the hospital, you with your board, multiple liveware interactions. And then there's the overall environment. So the environment which you work, the noise of the environment, the fact that you don't see natural light from the moment you get into work to the moment you leave. There's multiple environmental pressures on you, and then the C, the extra bit that's been added to reflect the culture. So the organisational culture, the national culture, the safety culture, all of these cultural elements affect the way in which humans operate. All of that has been constant. We've known about that for many years as we had an understanding of sociology and psychology. So we developed a safety system, and we look at data. So we collect enormous amounts of data. We analyze enormous amounts of data. We do investigations, as I say, on events with consequence and events without consequence. We identify risk. So we do a very proactive identification of what could go wrong. We assess risk and we treat risk. We do all of that. But we're still seeing events. So things are still not quite working as well as we would want to. So this crisis has really come to this point of, okay, we're doing everything we think we should. So why are we still getting events, and what can we do about it? I think the other thing which has changed considerably is a number of things. Firstly, the volatility of the environment in which we work. So we're seeing enormous change it's very fast and it fluctuates massively, so it can swing quite considerably. But also it's uncertain. So we're looking at a situation and we cannot predict further forward often than the end of our nose. It is that the world is so uncertain that we're not quite sure if we do this, if it's going to have the effect that we want to, or what is the trajectory of this particular incident, and so on and so forth. And you will have heard lots about complexity. So we are operating in an environment in which there are many interactions, there are many feedback loops, and actually we're never quite sure if we change one thing, what is going to be the effect elsewhere. And finally, the world is hugely ambiguous. So we don't know which assumptions we're making are correct, whether those assumptions hold for a day or a month or a year. Everything we do has so much ambiguity. This has been studied a lot, and clearly these are not independent, they're very interrelated. But these are some of the things that there's a lot of evidence to suggest this is getting more difficult, more volatile, more ambiguous, more uncertain, and more complex, which makes the old ways of doing things very, very difficult and less effective than we would hope. Now, one word on complexity. So this is a VW Golf decomposed, taken apart and all its parts, and it represents the way in which we do safety. We're very reductionist in the way we do safety. We think that we have a system. If we break it down and we understand all the little bits, then we'll understand how the system functions. And clearly that's not the case. If you have this is a complicated system, but it's not a complex system. And then you get situations like this where the US military tried to model the insurgency in Afghanistan. So they tried to understand all of the interactions that are going on at any time and the feedback loops. And clearly this is a snapshot of what they found. And actually it's so difficult to model and it's so difficult to understand all the links. And the relationships are non-linear. So you just don't know what's affecting what. So if we're facing this uncertain, volatile, ambiguous, complex world, what does that mean in terms of how we operate within that? Now, one of the words you'll hear frequently in all of this is disruption. So it's something that affects the way in which you operate. And those disruptions can be acute shock. So it can be something very sudden that has a massive effect straight away, or it can be a creeping chronic stress. But actually, both of them need to be considered in the way you do risk analysis and safety management. So what I've got here is a diagram to show, it's called a critical functionality curve. It has benefits, it's not perfect, but it's useful in this case to explore what happens when a system faces a disruption. So if we talk about a particular system has to deliver a particular function, suffers a disruption, and then you start to see its inability to provide that function. So its ability gradually drops away over time. In this particular case, the organization is unable to absorb it, they're unable to recover from it, they do not adapt, and they're no longer able to provide the function that they need to. And then you get systems where they have a disruption, they suffer the loss of functionality, the loss of the ability to deliver the function, and then over time they recover. They may never get back to the level of functionality that they were at the start, but they do recover, they do improve over time. And then you get systems, and we see this a lot, where you have a plan. So you have a business continuity plan, or you have a risk treatment plan, and you know we're going to suffer that disruption at some point. We have a plan. You suffer a loss. You slowly recover. You build yourself up, and you go back to being able to deliver the functionality. And that's essentially that's how we've operated up till now. We very much focus our safety efforts on identifying as much as we can and putting in plans in place to resolve them, to address them. So the key is, what can we do differently in the world that we're in now, when we talk about black swans, we talk about the things that we can't predict. So what do we do if we cannot predict everything? We cannot put a plan in place for everything. So how do we act differently? And again, what I wanted to do is to find some analogies that didn't involve pilots and ground crew and so on and so forth, but equally was out of healthcare, because I find from my own experience that examples taken away from the context in which you work are actually quite useful. This is a photograph of a volcanic eruption in Japan from the International Space Station. And what is interesting about this is that the accepted wisdom was that when you have hazy environments, the plants absorb less CO2. Well, actually what they found when they started studying plants around volcanic eruptions is that actually they get more efficient at photosynthesis. So the way in which they process CO2 improves. So actually what they're doing is they're taking the limited light that they have due to the dust in the atmosphere, and they're being much more effective at using it, which was something that was a relatively misunderstood concept. And then I looked for other metaphors, and I suffered a snowboarding accident, and I had an X-ray. So that's me from last year. And what I learned through that experience is that, and I'm sure many of you will already know this, but the skeleton replaces itself every 10 years. Now, again, I'm sure I'm vastly oversimplifying, but my understanding from research is that actually the skeleton is our biggest store of calcium and phosphorus. So we're constantly using energy to destroy our skeleton and rebuild our skeleton. And it's happening all the time. It's a process, it's a balanced process that goes on throughout our lives. If the body suffers a disruption, so if it suffers a break, for instance, obviously we lose stability, but then the body very quickly delivers calcium to that area. The break is repaired very quickly, and the observation to the layperson is that they have a lump under their skin. Now, actually, the body is very clever, and it then starts the process of breaking down what's not needed and replacing it with what is needed over the course of 6 months, a year, whatever the period is. So the body rebuilds based on the strain that it suffers. So you have gradually over time a repaired bone. Now, if you look at another disruption, so osteoporosis, for instance, is where the mechanism of destroying and rebuilding is disrupted. So we're actually breaking down more than we're repairing. And again, I apologize for a vast oversimplification for those of you who know more about this, but we don't really understand as much about that, but we are certainly, it is happening, and it's a disruption faced by the body. And then I looked to the brain. So neuroplasticity is so fascinating. So we have a very complex system, and over time we are building networks in order to, as we learn, so we're changing the way in which our brain structures as we learn. But also when we suffer disruption, so when we suffer a brain injury, it is possible for the brain to reallocate an entire function from a damaged part of the brain to a non-damaged part of the brain, which is amazing. And there's no one controlling that. There's no one deciding who is done. It is a complex system adapting to the situation and reallocating function to something that works elsewhere, allowing the body to continue to deliver its critical functionality. So if we take those, which actually are not metaphors of resilience at all, it is absolutely resilience in action. That is resilience. And this is the definition of resilience by Eric Hallnagel, who is one of, I guess, the godfathers of resilience. So if you have a quick look at that, I'm sure you've all come across the definition before. So some systems are able to withstand, respond, and adapt to disruptions, and not pre-specified disruptions, but any disruption, by preserving and even enhancing critical functionality. So they are able to change the way in which they work in order to continue to deliver the critical functionality. So how does that apply to organizations? Now, I've talked about resilience, and resilience is great. You know, we'd all love to have lots of that. But how does it apply to organizations? So the first thing is to dissect these things. What's resilience and what's resilience engineering? Now, I've talked about resilience, and that's the characteristics of the system. But actually, what is the engineering bit? And I hear from your introductions that a good number of you are scientists, and actually breaking and understanding that idea of resilience, how we do resilience engineering, is really important. So you can see here there's two ways of engineering resilience. One is where we do not understand the underlying mechanism which leads to the resilient performance. So this system is resilient for some reason. We don't understand why it's resilient, how it's resilient, but we can engineer solutions to support it. So a really good example of this is going back to the broken bone. There is evidence from Egyptian hieroglyphics that the ancient Egyptians were able to splint and knew how to splint broken bones and actually support the break so that as it repaired effectively. So orthopedic surgeons now have a lot more understanding of the mechanism, but actually they're not doing anything to the system. They're supporting the system to allow the resilience to do its thing on its own. So that's where we engineer solutions to support the resilient process. The other way of doing it is to say, okay, let's really understand the resilience. Let's really understand how we are achieving resilience within the system. And a lot of work is done to look at the system, to look at how resilient it is. And then when we understand the mechanisms underlying it, you then engineer solutions to manipulate it. So in the case of osteoporosis, you actually put in place a drug regime, once you understand this process of destroying and remaking bone, to actually readdress the balance. So then we have a much better understanding of what's going on. So those are the two main ways of engineering resilience into a system. And of course, that can apply to organizations. And my experience, so I'm on the executive committee of the Resilience Engineering Association. And this has been going, I think, for 8 years or so. And I go to their symposiums and I hear them talk. And so much of what the academic community is doing is trying to focus on understanding the mechanisms underlying resilience. So why is this system resilient and this one not? And how do we manipulate this to make it more resilient? Well, actually, I think what we do in healthcare, actually, we don't need to understand everything about how we're resilient, but actually let's do stuff to support that engineering, to support that resilience. And that's a lot of what I think we need to be focusing our efforts on. So in the case of resilience, a resilient system, what we're trying to do is, looking back at our functionality curve, if our system displays resilient performance, actually the absorption is much better. So we actually increase the amount of absorption. We can absorb more of this disruption than previously. Or we can actually recover quicker. So actually the system is able to recover quicker than it could before. Or we improve the residual effect. Actually, by learning about how we deal with it, we're going to be better placed to deal with it next time. So I can't believe I've reached this point without mentioning coronavirus. But the fact is that what we will do through coronavirus is really establish ways of working to engineer a better way of approaching these such that if we have a more serious epidemic or pandemic, we will be in a better position. And that goes across the whole country. So I'm a director in a healthcare business, and we're looking at how we change the way in which we work in order to make sure we can ensure that people in the community are served despite the challenges that we're faced as an organisation. It's happening at an organisational level, it's happening at a governmental level, and it's happening in each of your hospitals. And in order to deliver resilience, in order to engineer it, there's a number of capabilities that we can focus on. So the first is to anticipate. So if we're able to look into the future and have a better idea of the disruptions that we face, then we will have a better way of actually dealing with them and make sure that we can engineer solutions to address them. So this is the classical risk identification process. That is a scheduled fire alarm, so I think we'll wait a couple of seconds. So, yes, anticipate. So being able to look forward and really see what is going on in our environment, internally and externally, that could affect how we react to disruption and what disruptions we can face. There's then the ability to monitor. So this is day by day. What signals do we look for in order to understand if the system is deviating from normality, what can we identify very, very quickly about whether we're delivering our critical functionality or we're starting to deviate from delivering. So one of the things that John will be talking to us about is how we can use data in a better way. And my challenge to you is, what data do we look at? So we have enormous amounts of data, but what bits of data do we actually need to look at to really understand what is going on? And it is clear that we do not need to collect everything we collect, nor analyse everything we analyse, or try to understand everything we collect. So actually, how do we understand what to collect and what to analyse? And then there's our ability to respond. So how do we take the learning, how do we change the way in which we respond to a disruption to effectively ensure that we don't suffer the loss in functionality that we would have done before we were resilient. And then finally, obviously, how do we learn from it? How do we learn the right lessons from the right experiences? So again, how do we build that knowledge, build that organizational understanding so that we can deal with disruptions better in the future? So that's enough of my deviation from why we're here. So focusing very much on radiotherapy, and I'm afraid I'm going to start talking about aviation now, despite the fact I'm said that I would focus on radiotherapy. What I see in radiotherapy, and I am so far away from being an expert, it's untrue, but what I see is a highly proceduralized, highly regulated, highly protected, highly reliable, highly successful, and highly safe system. Now, you still suffer events. That is something that is inevitable. We will suffer events, but actually, the parallels between that and aviation are very, very strong. So, if you think about a cockpit, we see exactly the same thing. Hugely proceduralized. There is a standard operating procedure for pretty much everything in that cockpit. If someone dies in the back of the cabin, we have a procedure that tells you what you do in that case, as well as what is happening in the cockpit if you suffer a failure and so on. Hugely regulated, so we know what is going on, we know exactly what we should be achieving. Hugely protected. Now, one of the things I did is I took your taxonomy, your causal event taxonomy, and really started to pick it apart. And what I found is that you have 190 safety barriers listed in that taxonomy. You have an enormous amount. Now, and I don't know how the system has been built, but I can pretty much assume that it's done from very proactive analysis of what could go wrong, but it's also based on that. So if something goes wrong, we put in place a safety barrier. It is the way in which we operate, and it's been hugely effective in the past. It's exactly the same with aviation. So any of you travel on a plane, before you take off, you'll see, if you look out over the wing, the wing, parts of the wing lifting as you go. Now that is the test. That is a test done by the pilots into the fact that they can control the aircraft when they take off, which obviously you would want them to be able to do. Now, I was involved in an incident investigation where an Airbus aircraft took off, and then the Airbus aircraft, just to teach you a bit of flying for a moment, Airbus aircraft are controlled by two joysticks. So the captain on one side has one, and the first officer has the other. Okay, so it's fly-by-wire, so it's all, there's no physical mechanical connection. It's all digital. Now, the aircraft took off, the captain who was flying banked one way, and the aircraft banked the other way. So he instinctively increased the bank, and the bank increased the wrong way. Now, as per instinct from flying and the simulator, the first officer took over, and they're not decoupled, so one can take over from the other. The first officer took over, took the aircraft around, landed safely. And what they found was that one engineer had cross-connected two wires in the flight control system, and that's all it took for that. It should never happen. We worked tirelessly in Airbus to make sure cross-connections couldn't happen, but it did in that case. The reason that I explain it is that as a result of that incident, when you look out and you see what's going on, that one incident changed the way in which that procedure happens across the world. It is a new procedure as a result. That is the aviation industry looking at what went wrong and changing, putting in place a control barrier to resolve it. It works. We do it, and we should continue doing it. But the flip side of it is to look at why we're successful 99% of the time, or 99.999% of the time. What we're doing by focusing on that 1% or that less than 1% is to really lose the opportunity of learning from all the times that we do it. And actually that's where this becomes very powerful from a healthcare perspective, because we're doing work in healthcare every day, modifying the way in which we work according to the conditions that we operate in. So we are working around the system that we operate in order to deliver an effective, efficient, safe treatment for our patients. So actually, we're always doing these slight modifications and slight changes, but we're still delivering. We're still delivering 99.999% of the time. So we are treating patients safely. We're getting through to delivering the outcomes that we desire in a lot of the cases, but we are doing that in spite of the challenges that we face. So we all face challenges as we do our work. And there is a lot of research that says that practice doesn't meet policy. One study I was reading into hospitals is that there were on one, of the study that I looked at, there were 12 hospitals, 8,000 pages of policy, which ran to 2 million words for a particular hospital. And there's a lot of research to suggest that each individual cannot understand every single policy, every single procedure that is put in front of them. They clearly understand the ones that they need to perform the job that they do, but they are often practicing differently than the policy or the procedure requires them to. So what our challenge is to really understand that. So what we have is an ability to really start to understand day by day what is going on, how we are deviating. So despite the proceduralized, highly regulated cockpit environment, pilots are doing differently each day. They operate it slightly differently, they have their own way, and Simon is also from aviation, and I'm sure he would testify to the fact that pilots have their own way of flying, despite the fact that it's hugely proceduralized. And actually, there was a process developed that allowed someone to sit in between. So there's the jump seat, which is the seat that sits slightly back from the two people flying the aircraft, so that you can observe. And what the aviation industry has been doing for some time is putting someone in that seat to observe how practice deviates from procedure or policy. And this is hugely effective, because what we start to understand is weaknesses in organizational procedures, weaknesses in procedures of the manufacturer, and really start to pick apart what is going on and why do pilots fly differently than the policy or the procedure says that they should. That kind of approach is also hugely beneficial in any sphere. So actually observing how people really do work rather than how we imagine they should do work is really important. And actually this is the other key phrase that you will read a lot about. It's this idea of work as done versus work as imagined. So when the policy is written, when the procedure is written, the person that writes it, the person that designs the equipment or whatever, assumes they know how this is going to work. And they sit down and they say, okay, this is how you will use this procedure. And then they give it to the operator, and the operator uses it slightly differently than prescribed. So it may not be massive changes, but there are differences in how it's operated. So what we're always trying to do is we're trying to understand that deviation. What is the gap, and what is there a gap? And can we understand it in order to change the way in which we work going forward? So what I wanted to do was really just to lay the groundwork of resilience, what is resilience, and also talk a little bit about engineering. So how do you engineer solutions to actually improve them? And I think there are some key things that that you can adopt going back to your desk tomorrow. So data, investigations, risk assessment, risk identification, risk treatment, all of the things that we've done before. Just a few pointers on some of the things that you may want to adopt in your practice going forward. But there are also some ways in which you can change more fundamentally. So I just want to talk through some of those. If we use data more effectively, we can really reinforce our ability to anticipate, our ability to monitor, our ability to respond and to learn. And I'm not going to talk any more about it because John is here and he can spend a lot of time talking about that. Equally, investigation, Simon will talk about. Equally, it has massive potential to change the way in which we operate, and really to build resilience into the system in which we're working. As I said, a lot of work I do is on risk, and actually there's some really important things about risk. We are very focused on what can go wrong in risk assessment and risk identification. And actually, one of the things that we can do is to take a step back from trying to identify the risk, but actually trying to identify the latent conditions. So what is it that's going on a day-to-day basis? Going back to our seashell model, what is going on that influences people's performance that can lead them to on a path to making a mistake? So what is it that's going on? But equally, how can we change those to ensure that they're getting it right more often? And it's that change of mindset that's really important. So really to focus on those latent conditions. So what is it about the way in which you operate that forces us to deviate from the way in which we intend people to work? I think one of the things about black swans, and if I had more time, I would spend more time on black swans, is these supposed events that come from nowhere. No one has any idea. And if you've read Taleb's book on black swans, which I highly recommend if you're in the field of risk and safety, he talks about a turkey before Thanksgiving. So a turkey wakes up each morning for its whole life, is fed well, is looked after, and then the day before Thanksgiving or a few days before Thanksgiving, its head is chopped off, and it is a catastrophic disruption for that turkey. Actually, so from the turkey's perspective, it was a black swan. I've been looked after, I've been here for my entire life, and suddenly I'm no longer. But the butcher or the owner of that turkey knew that it was going to happen. So the thing about black swans is that often there is people with knowledge that this is going to happen. So your job in identifying risk is to seek out the people that know what's going on. And we have examples, from 9/11, from the financial crash, of people saying, "I think there's something not quite right here." And actually, it's trying to really listen, to actively listen to the things that people are saying. In risk assessment, I think that the biggest problem we have with risk assessment are RAG charts, red, amber, green, and we focus very much on, is it a red risk or is it an amber risk or is it a green risk? And actually a lot of that is hiding the underlying uncertainty that we're facing when we do risk assessment. So actually the entire process of risk assessment is based on assumptions. So we need to really understand how confident we are in our assumptions and to review those assumptions regularly. Really, it is the most important thing about risk assessment. When you're putting in front of the board a proposal, really let them know the proposal, the uncertainty on which that proposal is going. On some you will have lots of certainty or more certainty than others, so really focus on that when you present solutions. The other very underestimated part of risk assessment is exposure. So one of the things that we do a lot is focus on exposure. So one of the areas I'm working on at the moment is the maintenance of helicopters. Now, you talk about 190 safety barriers. Well, on a helicopter, sometimes you've got 3. Okay, so 3 safety barriers before that helicopter takes off and a rotor blade comes off and causes a catastrophic loss of the helicopter. So this idea of exposure, if you have to maintain that part that's only got 3 safety barriers once a day, then your exposure to the risk is massive compared to doing it once every 50,000 hours when you have to replace it. So when you're talking about risk assessment, focus on your exposure to the risk and place your emphasis not just on how catastrophic it is or how likely it is, but how exposed you are to it. And that's something to just bring into your risk assessment. And as I say, really focus on the assumptions that you've made and the uncertainty under which you're making them. If you talk about risk treatment, some of the things that we need to do in risk treatment is really focus on solutions that aren't based on certainty in an uncertain world. So when you look at something, you identify a risk, you assess it and say, okay, the solution to that is X, and you put in place one other solution that really focuses. Now, it's based on uncertainty, so you don't know whether that one thing is going to happen, is going to have an impact. But actually, if you think about it as an adaptive policy, so actually, if you've got something in place and say, we're going to do this, but it's designed in such a way that if the conditions change, then it changes with it. A good example of this is fatigue management in aircraft. So fatigue is a massive problem and has caused many aircraft accidents, and there was a huge amount of focus on how we can improve fatigue management. And now they're following huge amounts of research. There is now software that allows the people doing the rosters to put in the shift patterns of the pilot so that it can adapt the forward-looking shift patterns to take account of fatigue. So it's not a very simple, this is your shift pattern for the next 6 months. It adapts day by day, month by month, to account for the fatigue within the individual. So that's very much an adaptive policy. And I would also recommend doing experiments. So where you can look at, if you've got two potential solutions, can you implement them on a very small scale to actually see how they work? And can you run multiple experiments to see which ones work and then which ones you implement? This is something that's employed all the time in software. So Facebook, for instance, changes its code every 3 seconds. And some of you open Facebook to others because they're running little experiments to see what works and what doesn't. Obviously, a lot easier than in a software environment than in the environment in which you work. But really start to think about whether there is anything you can do to try things out on a smaller scale. From my experience of looking into healthcare, I think the biggest issue that I've observed is amazing, great creative ideas. But of those great creative ideas, a very small percentage actually get implemented, and a very small percentage of those actually remain implemented over a long period. So this idea of closing the risk loop, of actually saying not just, okay, I've got a great idea and this is a great proposal, but actually continuing to follow that to ensure that implementation achieves what you hoped of it. And that is a really important factor in the whole element of risk treatment. Now, a couple of new things that you can do, and this is not things that you could immediately go and do as you went back to your desk tomorrow, but really some of the things you may want to consider going forward. In the design of new facilities, the way in which facilities are arranged has a massive impact on the resilience of the overall system. So we're involved in a research project with Mayo Clinic in the US on how you actually change the way in which you design facilities by involving everyone in the team, by having continual conversations throughout the process of design to ensure that you do it based on something called functional scenarios, and I don't have time to go into it, but if you're interested in that, if you're redesigning facilities, drop me a line and I'll explain more. There is very good ways of modelling this, how resilient is your system. Now, this is very complex. I'm not a specialist in it, but there is something called the functional resonance analysis model, I think FRAM, which is a way of modelling this this resilient capability. So you may want to think about that, certainly in some areas. There's also ways of measuring resilience. So again, I'm not a specialist, nor, based on what I said before about the fact that I don't really think we understand resilience, certainly not in the healthcare domain. I don't have a lot of confidence in this, but you know, I know many people do. There's lots of research out there that's emerging how you can start to measure resilience. So there's 2 examples here. One is Eric Hollnagel's resilience assessment grid, and then there's Human Breed's resilience at work scale. So again, there's 2 things that you might want to look at if you're interested in this as a way of understanding how resilient you are as an organisation. The other thing which is hugely beneficial is the idea of competency. So the really impressive push from it within the NHS to change patient safety and all of the work that you've seen over the last year about a different way of doing safety. So much of what I've said is embedded in that. So there's some really interesting things, but one of the really interesting things that come out of it is the syllabus. So there is a syllabus which some of you may be aware of, very, very new, which basically states that what every person that works within the NHS should know about safety, and really starts to build on, okay, what do they need to know, and really focus on those areas. But there's also an element of, okay, you as safety specialists within the NHS, what do you need to know, and how much do you need to know? So one of the things that Isabel and I talked about doing was to create a survey out of this, for you to really understand your own capabilities, your own competencies, but also as a special interest group to drive future training. So there's material being written by the NHS, but equally, before that arrives, there's other things that I can come and talk on, and I'm sure Simon and plenty of others. So we can really start to have an understanding of this room and where your strengths and where your areas of improvement lie, and can that drive future events. So that's one that we'll talk about again later. I think that the most important thing and the best thing that I've seen, the biggest development within safety, within health, is this idea of conversations. And what I have seen is talk about huddles and debrief and brief, safety conversations. All of these things are really about engaging with everyone within the team to really have an understanding of not just what the policy says, but actually what is practice. What are the challenges to practice? What are the things that are underlying the situation, that are not clear from the data, they're not clear from investigations, but actually it's this deviation between the way in which we imagine work is being done and the way in which work is really being done. I think some of the things that I've observed in my discussions with healthcare practitioners is, how should we be having the conversation, but also who should be involved in the conversations. And I think that that's two things that perhaps we can talk about briefly now. The aim is to encourage the sharing of experience to support action. So people, there's no point in having safety conversations if nothing happens as a result. So what we want to do is we really want to understand what action to take, and then we really want to generate learning from it. But we don't want to do it once. We want to do this consistently, and we want to keep revisiting. We want to assure that what we've done is working. We want to take learning from one another to apply. And our answer to that problem, and an answer that is by no means new, is an action learning approach. So I'm sure many of you are aware of the action learning approach, but action learning was designed a long time, many decades ago, as a means of stimulating learning, but also focusing action. And it's a very, actually it comes in many forms. The form that we have implemented, so Mary, my business partner, and I have implemented hundreds of times with thousands of people in public sector, private sector, in health, in aviation, in property, in fashion, all manner of organisations. Anywhere where you've got people working together, where you want to understand this deviation between the work that you imagine the work has done. And what we're trying to do is we're trying to stimulate that conversation. The key to it, in our mind, is to have more structure. So if you just say, okay, well, it around that conversation. It's actually quite difficult to start the conversation. It's quite difficult to generate the action and then to create the learning from it. So actually, what we have done many times before is this concept of a much more structured action learning approach. For your sins, you will be trying it shortly. It's about active listening. It is there is no rocket science in any of this. It's about listening well. It's about hearing the words used, not just the intent, but actually which words were used. I've been in action learning sets where people have said, I don't believe it, 6, 7, 8 times. I don't believe it, I don't believe it, I don't believe it. Well, actually, you can challenge that. Why don't you believe it? And actually, hearing the words used is so important. Body language, as we know, is hugely important. So actually, people who really, even very subtle changes in body language can have a massive impact on what is going on and your understanding of what is going on. The key in action learning is to spend time on analysis, okay? And I'm very pleasantly surprised by radiotherapy and the fact I'm talking to lots of engineers and scientists, because actually you are the worst at this, okay? And I'm one too. So we rush to solutions so quickly, and actually when I'm in an action learning set, the facilitator is always dragging me back, despite my knowledge of the process. We need to stay in analysis. We need to spend time analysing, not rush to solution. The other thing is to assume that the person raising the issue is able and competent, so the issue is difficult. So we really need to support them and understand them. So in this structured process, there are 3 main roles. There is a presenter, so there is someone that puts their issue, the issue that they're facing, on the table. Then there's someone that keeps time, that facilitates, that hosts and cares for the person. So their role is very much to care for the person presenting. It can be a hugely challenging experience to put these challenges on the table. So there needs to be someone to care for them. And then there's a note taker, someone that's taking notes, and they're taking notes for the person raising the issue. And it's not for anyone else, it's not for the group, it's for that person. You want to give them something to support them. And that's what we're going to be doing today. It's also structured in its use of time. So we recommend a quarter of the time is spent by the presenter talking about the issue, and then allowing questions to actually make sure that people understand. You spend half of your time on analysis, and I'm not going to be able to be in each one of your groups the whole time. So I'm going to ask you all to be listening to one another to make sure that you're not rushing to solutions too quickly, that you are focusing on analysis for at least a quarter of the time. Then you can be let loose on solutions. So really think creatively. And this is where we need to bring, and this is the idea of really thinking outside of the box, to use the massively overused phrase, but really think of creative ideas and don't be limited by what you've done before. And then the last 1/8 of the time is to spend for the presenter saying, I really like that idea, I'm going to do it. And also for all of you to say, what have you learned from this experience? So actually, you may take something away. In fact, in my experience, everyone takes something away from this conversation. The key, however, is to do it again. It's to come back to it. So a lot of this is what I've said. Really understand what's going on, spend your time on analysis, don't rush to solutions. The action taken is taken by the issue holder. The issue holder will go back and deal with things. Now, that's not always the case. Okay, so we should say in this particular circumstance, it might be that you as the quality manager may be facilitating this. There may be actions on you to take away. But actually, in a lot of cases, the problem holder can take away solutions as well. So we will encourage them to implement the solutions, and then when we come back, actually review them. So the learning is embedded not just in the individual that takes the action, but actually in sharing it throughout the team. So so it's not about success and failure, it's about the lesson that was learned. The final question is, who should be having the conversation? Now, I it is my belief that you guys are sharing similar problems. You're sharing similar challenges, you're sharing similar solutions, and it is a great opportunity for you to do this on a regular basis. So to form action learning sets, to talk about this, and whenever you come together virtually or physically, to revisit some of the issues that you faced, to put them on the table, to say what worked, what didn't work, so that you can share the learning across your organisation. But when you talk internally, it's about you and your teams. It's about you and your management and boards. It's about you at a very small level and you at a larger level. And the work that we're building, so I've done action learning sets in different ways, but it is very powerful when you have nested action learning sets. So you have action learning set at a team level, and then you have it at a higher level where you bring managers together and have an action learning set of managers. And then you're able to bring the learning from one and pass it all the way through an organisation. The other thing which is hugely valuable is bringing the patient experience in, and there's lots of talk about patient-centred healthcare and so on, but actually, again, bringing the patient and their families in to really understand the challenges they face. Action learning is a perfect mechanism to do that. The final thing to talk about is involvement of the original equipment manufacturer, the OEM of the equipment that you use. So a lot of the work that I do is bringing the people that design helicopters together with the people that operate helicopters. So I spend a lot of my time looking at safety critical maintenance procedures on helicopters, and the designer of the equipment and the person that wrote the procedure has sat down with the person that does this on a daily basis, and they say, oh, I never do that because of X, Y, and Z. And the OEM says, oh my God, why are you doing it that way? We wrote it this way for a reason. But really, then you have the opposite effect. And actually, the OEM says, yeah, you're right, there's an error in that procedure, it should be the other way around. And actually, what we're really trying to get to is where just the role of the equipment, and especially in radiotherapy, the role that the equipment manufacturer plays in making sure you have safe outcomes. So really involving the OEM in those conversations is hugely valuable. Massive parallels, and I wish I could talk more about it. But if you're interested, then shout and we'll talk about it in one of the breaks. So. As well, can you tell me the time, please? I don't have the 10:36. Okay, so we're due to break 11. Okay. What I'd like to do is we're going to spend half an hour, so we'll stick to the plan. Of doing that, we will eat into your break by a few moments. One of the principles of action learning is not bringing back and presenting to the room, because the issues raised are supposed to be something that that are not for public. It's about the set, it's about the action learning set, it's about the group owning that section and it being very open. Now, this form is very different. So I would recommend that we don't bring it back to the group, but I would, if anyone wants to, then please shine. So the exception will be not if anyone really wants to talk about it. You all had your moment of fame from the camera today, so there's no need to force it upon you. So what I'd like to do, I think we're going to have to amalgamate some tables because this works best in 6 to 8 people. I wonder whether we can. Would you guys mind joining this table? And would you mind joining this table? And then, John, did you want to take part, or are you going to head out? I'll go quietly say no. Okay. Can I ask you guys to join this table? What I'd like to do is for you to spend literally 1 minute suggesting something that you may want to talk about. So it can be an issue that you're facing within your organisation. it actually can be anything. We've had people talking about their commute to work. We've had it doesn't need to be anything focused on the day job. But the issue that what we're trying to do is really understand the process. So I would ask one of you to, and Isabel, did you come up with issues that are common that remember you were going to come up with some common issues that people may choose from?
So I think a lot of us have incident related to the CBCD, filter, where our operator every now and then gets so this is one issue I think we discussed at regional quality safety and like the survey. So this is one example, and I think it's starting wise with the okay. Sorry, and also while we're going to have you come to those specifically in your area. So I think the imagination is
Yeah, so those are issues that you can address if you wish to, but equally, all I would ask is that one of you steps forward quite quickly with an issue to discuss. Then I would say you're probably going to have about 6 minutes to talk about that issue. So really delving into the issue that you face, and really doing your own analysis of it, what you've tried, what you haven't tried, and how what's worked and what hasn't worked. Then I would ask you as the presenter to sit back and to listen, for the group then to analyse it and to really start to pick it apart and to understand what is going on. Where possible, do not ask any more questions of the presenter, because actually what you're doing is basing on the knowledge that you've got already. The risk is that the presenter is just drawn into all of the analysis, but actually work on the information you have. Then I'm going to tell you when you've reached these critical points and you swap to solutions. So start to bring your solutions out and start to raise the ideas that you've got. And then the final 3 minutes, just the presenter coming back to say, like it, I'm going to try that one. Of course, the idea would be that you would then repeat that, ideally within the next couple of months, but whether you're going to have the opportunity to do that, I don't know. That's what we're going to try. I'll be coming around. As I say, I'll let you know when you've reached the changes between these. I wouldn't normally do that, but it's probably it's not feasible for me to try to facilitate all 4 groups. So, over to you. If you can pull your groups together and then. Oh, great.
yeah, so maybe so we have 3 groups.
Yeah, 3 groups. Yeah.
And it's just John knows he's John, they know he's John, but it's very good. We have to hold them by the Q&A and then we'll sit back for the rest yeah, and so this is the way to get into our first oh yeah, that's absolutely. I don't know, that's a very simple one. I don't know when you get to oh my goodness, we haven't got all day.
How can we identify patients?
Okay, so the idea was that you had to really pick a product up from it. So, whether it's something that's blind, we think about it in one and or the second marriage, and then three different so really just obviously everyone does not agree with it, so they will have to all like it. And that's how all those pulling up to the operation ABR and then the site there. I guess the lack of behind. So and then possibly. Yeah. I mean, I've always very informal paper. Yeah. And you know, then I'm aware as well. So we'll put it onto the alert. And it should also be oh, absolutely. Sorry to interrupt and rush you along. We're going to move into that. So at this point, we would ask the presenter to not say as little as possible, and based on what your own knowledge, experience, and what has been told, to analyse it against which they really have. Yeah, that's not quite the idea, but you know, you can sit back and enjoy. Yes, what I will encourage I think this is very nice.
Yeah, and then you'll identify and I think I have there was something that you gave me sorry. Actually, we've got the but I
Very secure. It's on its own. About halfway through. If everything hits SSD as well,
one of the machines takes its way up in the around and it's all that patient and the individual needs all the other ones. They're not open to it. So one, that's because we didn't know all the maybe it's not well, I mean,
sorry, we're probably talking like
For me, it's very simple. When you buy something, all of you get contact with not work at your hotel. You can't have everybody particular. That is when your life is very simple. Life is very complex. That's the thing that you want. So, as a medical director, you always before you all stand on everybody got but you also in contact. In the contact with any partner, any problem, that's the government. That is how you question. That is how we got MRI. Because everything only working.
Yeah.
It's a teamwork. Team stands for together, everyone is
yeah, that's just the next stage.
I do work with every department. That is a standard.
But I was thinking about like late last week. No, but I remember
Yeah. Jump to a solution. You've got 3 minutes to listen. Your engineering.
Yeah, yeah. So it's
A minute left on solutions.
You can look at superficial patients available.
I would definitely recommend that and see this. It's early
well, so yeah, so it's sometimes it's Wednesday, so you can't really work. Yeah, yeah.
It's not about what made it. It's you want to get all. Yeah. It's very good. I'm not saying right now, so you can't remember this. The end result is making we've had everyone back to US presenting, and so the hit of the solutions is one you want to get down about the left and right.
Right. Well, I think I'm going to find out whether our local yeah. Yeah, I mean, obviously, like
Right. If we could bring it back to the room so that we can just wrap up quickly. I am sorry that I did rush you through so quickly. Hopefully what you can see from that, you only saw a portion of it, because the next meeting is you would reconvene and you would then be able to discuss the... Simon? You can see a small proportion of it. The idea is that you embed the learning by coming back together to say, this is what I did, and this is what happened, this is what worked, this is what didn't happen, and then someone else will raise an issue. So clearly, as I said, this can happen on multiple levels. It can happen in a conversation between you and the LEM, it can happen at a group like this, so you could run one of these every time you have an annual meeting. Or a regional meeting, you could have this within your teams. to really get them to start to talk about the issues that they face and what they can do about it, as well as what you can do about it to solve them. We did have a very quick run through. Hopefully you've got a taste of what it can do. I would encourage you, if you're interested in resilience, you want to know more, there is the Resilience Engineering Association. They run monthly webinars on different topics, and they've got quite a lot of resource on their website. So have a look at that. And equally, if you want to get in touch with me and some of the work that we do, my website. So thank you very much for rushing through that today, and I'm around all day, so please have any questions specific to your presentation. Thank you.
Just one thing, so I'll try to put up like a few, it's called, but I will put them like a little poster up so that you can see what you're interested to learn more. Like I said, like with the community, we'll be able to organize maybe more like specific training sessions in the future. So if we can like engage how much interest we have, then we can definitely organize that. Probably virtually, but we can be creative. I'll put that up. And there are, I think there are some like books Is it? Oh, right. Okay. I'll try to find out and then leave it on this table. So you can use those dots as like your goals to see, like, if you're interested in any of the subject, like, we can just put a dot in it and then so that we can organize things like, for the future. And then I think in one of our regional policy meetings, we talk about kind of like common usability issue of our equipment. So I prepare like a summary of all the kind of common issues, like, departments, like, different departments posted. So again, this is really just to gauge, like, give us an idea what's the issue, like, people experience, more often. So again, if you pick up the dot and once we find it, pick up the dot and then put it on, and then say that just so you can get an initial idea. Rebecca from MHRA, she's not able to make it because of Corona, and they have to do a lot of contingency work at the moment. But we'll definitely feed that back to her so that maybe we'll be able to influence the MDR, the medical device regulation, and the radiotherapy guidance they're working on as well. So yeah, I'll put them up. And so during your break time or tea break or lunch time, please go and do it. Okay. Right.
Sure, yeah. Sure, yeah, we'll do that.
So as usual, all the presentation, all the slides will be shared via the group page because they are quite a big file. So possibly I won't email them to the group. You just have to log on to the NHS network. Okay. Right. So shall we come back? Say 11:45. Right. Okay.
And to those of you on Zoom, thank you very much for joining us. Sorry you couldn't take part in that final exercise. We are taking a short break. We're coming back at 11:45. Thank you.